we're going to be given ax squared plus bx plus c is equal to 0. And we want to prove that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Many of you have seen this formula before. If I can zoom in on that, let me see. Yes. Oh, it's cutting into my image a little bit. This is not as easy as it looks. There, that's pretty good. All right, so we're going to prove this. All right, so the first thing we're going to do is divide by a. So if we divide ax squared by a, we get x squared plus b over a times x plus c over a is equal to 0. 0 divided by a is 0. Then we're going to subtract c over a from both sides. So then we get x squared plus b over a x. I'm going to leave some room because I'm going to be completing the square. So minus c over a. So if you move something to the other side, you change its sign. So then we take half of the b term and we square it. That's called completing the square. So I'll do that over here. Can you see me? All right. So half of something is to multiply it by a half times b over a. So that's the scratch work, and we want to square this. So this gives us b over 2a squared. Then when you apply a square to products and divisors, you distribute the square term to all the items. So this is going to give us, I guess we don't need the parenthesis now. So this doesn't stick on very well. So I'll just leave that over there. So this would be b squared over 2 squared is 4, and a squared is a squared. So this is what we're going to add to both sides. That's called completing the square. So you take half the b term and square it. I did that scratch work over here. So that's going to give us plus this b squared over 4a squared. B squared over 4a squared. And if you add something to one side of an equation, then you also add it to the other side. So plus b squared over 4a squared. So by having this halving this term and squaring it, that allowed us to factor this with one of our special factor products. X plus this b over 2a squared. So if you FOIL this out, you would get x times x, which is x squared, plus b over 2a, plus another b over 2a, that's o and I. That gives you 2b over 2a, and the 2's cancel, leaving b over a, x. Then b squared, this is the squaring part, that's what our scratch work did. This will give us b squared over 4a squared. So you can see it FOILs out perfectly. This doesn't, they don't have common factors, so I'm going to rewrite this over here, minus C over A. And I'm going to erase it here because I need to do work on this term. Alright, so in order to add these, I need to get common denominators. So the LCD of these two things is 4a squared. This already has 4a squared. So I guess I don't need the plus sign. Alright, so in order to get common denominators, I need to multiply top and bottom of this this term by 4a. So now we have common denominators, 4a squared. So this is going to be equal to b squared minus 4ac all over 4a squared, the common denominator. So next we can take the square root of both sides. So the square root of a square is technically absolute value, but the absolute value means plus or minus. So I'm going to put the plus or minus on this side. So this is going to be equal to x plus b over 2a is equal to plus or minus the square root of this mess, which is b squared minus 4ac all over 4a squared. How are we looking on the camera there? That's pretty good. Alright, so the square root of a fraction is the square root of its component parts. And so this is going to give us x plus b over 2a is equal to plus or minus the square root of b squared minus 4ac all over the square root of 4a squared, which is 2a. It's technically 2 times the absolute value of a, but just plus or minus covers that. So we can just write 2a. And we're covered by the plus or minus. Okay, then we can move this b over 2a to the other side by changing its sign. So x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And these have common denominators, so we can put them together. So the numerator is going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. So there you have it in a single stretch, my little scratch work. So we get the quadratic formula on the general quadratic equation by completing the square. I guess I need to look over here. By completing the square. And so you can see that I have proven that the quadratic formula is what we said it is. So when we complete a proof in math, we write QED. Can you see it? Yes, you can. So we write QED. It stands for Latin, I don't know. It's 3 Latin words, which means, so we set out to prove that which we proved that which we were supposed to prove. So anyway, this is my first math video. Hopefully you like it. Watch some of my other content, please. Subscribe and like. Share my videos. I'm a critical thinker. I'm trying to become a science communicator. And thank you for your time.
What's math good for? I'll tell ya. The receipt is a paper trail of variables, tracking the milk, the flour, the perishable. adding the sum of the weekly shelf stock against the clock of the balance sheet lock. Then looking ahead, the long-term projection, a house in the distance, a capital section, compounding the interest year after year until the retirement budget is clear. What's math good for? I'll tell ya. It's the logic that moves and compels ya. Not some fable written in the dark, but the steady of the rational spark. What's math good for? I'll tell ya. The glass in your hand has a logic of light, signal processing working deep in the night, algorithms weaving the voice through the air, precise in the timing, precise in the share. Then look to the road where the iron turns, where kinetic energy shifts and it burns. Torque on the axle, friction on the street, calculating the path so the movement is sweet. What's math good for? I'll tell ya. It's the logic that moves and compels ya. Not some fable written in the dark, but the steady of the rational spark. What's math good for? I'll tell ya. Entropy gathers in the corners of rooms, but we map the patterns where the chaos looms. The dice roll hard against the brick of the wall, but we weigh the odds to endure the fall. It isn't a miracle, it isn't a grace, it's measuring space in a dorsorally place, turning the random to a structure of choice, giving the quiet of numbers a voice. Yeah, it's just the mechanics of the real. Everything else is how we feel. I told you.